This is day 3 of section 9.6, and for our example today, it says a committee of 5 is to be chosen from a group of 8 people. If that were the end of the problem, this would be 8C5, problem finished. But what's happening here is we're breaking down the big group into smaller subgroups. So specifically for this one, we're talking about men versus women. So the group of 8 people consists of 3 men and 5 women. How many different ways can the committee of 5 be formed? So it must consist of 2 men and 3 women. So for the visualization of having some understanding of what's going on here, we're going to let the 3 men in the group be represented by ABC, and we're going to let the 5 women be represented by VW, XYZ. So we want the group that we pick to consist of 2 men and 3 women. So if we have 3 total men to choose from, and we want 2 of them, 3 choose 2, or 3 ways to pick the 2 men for the committee. So making a list for that, it would be AB, AC, BC. Now order doesn't matter. The group AB is the same as the group BA. There's no like president and vice president in this group. You're either in a group or you're not. Okay. Now for the women, there's 5 total women to choose from, and we want 3 of them. So 5C3 is 10. There's 10 ways to choose the 3 women for the committee. So this is a list of all the different ways you can pick 3 women from a group of 5. So now what happens is we need to make one big group or a committee that consists of the 2 men with the 3 women. So AB could be paired up with any one of these. AC could be paired up with any one of these. BC could be paired up with any one of these. So the 3 groups of the men with the 10 groups of the women would make it 30 total committees. And not that I'm going to read all these off to you, but those are the 30 different committees that are possible. Now, as far as what you would actually do for solving this problem, you're not going to make out this list here of 30 different possibilities for every one of these. So what you're going to do is you're going to have an NCR for each one of the subgroups. So the 3, they represent the men, and the 5 represent the women. So from the group of 3 men, we want to choose 2. From the group of 5 women, we want to choose 3. 3C2 is the 3, 5C3 is the 10, 30 possible combinations here. So what happens here is we have a blend of the 2 strategies. The little parts of the problem are combinations, and then it's a fundamental counting principle with combining those together to get this to 3 times 10 is the 30. All right, a variation of this. What if the question was changed to how many different ways can the committee of 5 be formed, so it must consist of at least 3 women? So at least 3 women in this context means it could be 3 women, it could be 4 women, or it could be 5 women. So we have 3 of these guys being added up. That, plus that, plus that. So this part is the same as this right here. That's the what if there's 3 women. Now what if there's 4 women? That means there's only 1 man. What if there's 5 women? That means there's no men. So we get a grand total of 46 for that.